Okay, so welcome to the 20th class of Computer Architecture and Organization. So in this class, in the last class, we have discussed the topics like what is meant by ARM and all these things. So last class is the starting of the first third unit, isn't it or not? So in the last class, we have discussed about. So I will just rewind the last class for 5 more minutes because as it is a new unit, I want to remind you once again. Okay, I have told you previously, there is no hurry for us for this third unit. It is very simple unit with limited number of topics. So I will just explain you in a slow manner, and I used to remind you at regular intervals of time so that if you follow my video thoroughly, you can get the entire knowledge. Okay, so what is the name of the our third unit is instruction types. Okay, in these instruction types we are going to discuss about the instructions of a um, of ARM processor. Okay, so of ARM has two things. One is it is a processor there, and controllers are both are present in a ARM. Okay, so now we are going to discuss the instruction set of ARM. ARM. ARM stands for Advanced Risk Machine. ARM stands for Advanced Risk Risk Machine. RISC stands for RISC stands for Reduced Instruction Set Computer. Okay, so in the last class I have discussed what is the reduced set instruction computer and what are its advantages compared to CISC. Okay, so if you want to take any data from the memory or if you want to store any data from the into the memory now, okay, you can do them only by using two instructions. One is the load instruction and the other one is store instruction. That means either if you want to insert the data into the ARM or if you want to take any data out from the ARM, you can do them only by using two instructions. One is load instruction and the other one is store instruction. Okay, so in RISC also there are only two important instructions like load and store. So as the concepts in our ARM are similar to the concepts in RISC, we can say that it is following the RISC architecture. Okay, and we have also discussed about this register organization and everything, isn't it or not? It has a total the size of each register is 32-bit in ARM. It has 16 general purpose registers, R02. Total it is having 16 registers, R02, R15. Among them, 15 are general purpose registers. They are numbered from R0 to R14. Okay, and we have another register called PC, program counter. Okay, the program counter used to store the address of the next instruction which is to be executed. Okay, and coming to this one, what you will call CPSR. Okay, program status register. Continue. So what does it say? CPSR means current program status register is there. The size of the current program status register is also 32-bit. Okay. Among these 32 bits, we are having 4 flag registers. What are the 4 flag registers? They are nothing but these things: negative flag, carry flag, zero flag, and overflow flag. So negative flag, zero flag, carry flag, and overflow flag. These 4 are the flag registers in a current program status register, which is of 32-bit. Okay, so we need to discuss about those 4 flags. We have already discussed. Carry flag will be 1 whenever you get a carry. Negative flag will be 1 whenever the output is negative. Okay, zero flag will be 1 whenever the answer is 0. Like that we have discussed. Okay, so now we are moving into the next topic called memory access instructions. Memory access instructions. So what is meant by memory access instruction? As we have told in the previous class that first of all, what is meant by memory accessing means we are using the memory. Okay, for what purpose you use memory? There are two purposes why we will use memory. One is either to store the data into the memory. Second one is either to take or remove the data from the memory. Okay, these are the two things or two purposes where we use the concept called memory. Okay, we will use memory either to store the data into it or remove or retrieve the data from it. Okay, so that what he is trying to say is memory access instructions means in a ARM we are having each instruction in ARM is encoded to a 32-bit word. That's what we have discussed in the previous class now. Size of each register is 32-bit. That means the board length is also of 32-bit. That's what they are mentioning here. Here, what he is trying to say is each instruction in ARM, it will be encoded into a size of 32-bit word. That means in ARM, the word size is 32-bit. The word size is of how much bit? 32-bit, and it is in a reasonable uniform way. Okay, access to the memory is provided by load and store instructions. That's what we have discussed. There are only two instructions by using which we can access the memory. Accessing the memory means either inserting the data into the memory or taking the data out from the memory. This can be performed by using two instructions. One is the load instruction and the second one is the store instruction. First one is the load instruction and the second one is the store instruction. What is meant by load instruction? I have told you previously, whenever we want to discuss, we need to discuss about the load and store. You just remember the lorry example, house shifting example. Okay, you want to shift your home from one place to another. For that purpose, what is the first thing you need to do? You need to take all your particulars. The saman everything you need to transport them from one place to another. How can you transport them? Okay, you will book one lorry or at least a what do you call big auto based on your based on number of items you are having. Okay, so they will come and they will load the lorry with whatever the items that are present in your home. That means they will load the lorry with the fridge, with the double cot what do you call double cot bed. Okay, next they will load with your TV. They will load the lorry with your refrigerator, with washing machine, what all things. So here loading is nothing but previously the house is used for storing purpose. Okay, you used to reside in your home. Okay, so it is used for storing purpose. But now we are so. But whenever you are doing loading operation means you are taking the data from the memory and you are going to place it in a device which can be moved from one place to another. Isn't it or not? As house cannot be moved from one place to another, we are taking the help of a big auto or a lorry to move from one place to another. Okay. So loading is nothing but here the data is going to be transferred from memory into outside world. Okay, generally the outside world is nothing but it will transfer to the outside world with the help of a register. With the help of a register. That means load operation means the data is transferred from memory. Load means the data is going to be transferred from memory to the register. To the register. That means the data transfer is from memory to register. Okay, whereas coming to the store operation, it is the reverse operation. See, you have loaded your lorry with all your items and the lorry started. Here lorry is nothing but register. Okay, it reached to your new home where you need to shift your vehicle. Shift. Okay, so after reaching the home, what the workers in that particular lorry they used to do? They used to take all those things, your bed, double cot bed, or your refrigerator, or your washing machine from that lorry, and they will place it in the new home. Okay, that means they are storing it somewhere else. Okay, that operation is called store operation. That means in a store operation, used to transfer the data from the registers into some memory locations. So in load operation, the data used to transfer from memory into a register. Whereas in the store operation, it is an ulta. Here the data is going to transfer from register into a memory location. Okay. So these are the differences between load and store operations. I think you all are clear. Okay. Next, so as we have discussed previously, the size of an ARM is 32 bit. How much bit? How many bits? 32 bits. Whether it is a register size is also a 32 bit. Okay, word length of ARM is also 32 bit. Okay, so here we can access the data in ARM in multiples of 8 bit only. That means if you want to store the data in a ARM, or if you want to take the data from the memory of an ARM, you can do it in the multiples of 8 or 8 only, 8 or multiples of 8 only. That means if you want to insert the data, you need to insert at least 8 bit of data, or 16 bit, or 32 bit, or 64 bit, like that. You cannot insert 4 bit, 6 bit, like that. Okay, see, take one example that I have inserted 8 bit of data. I have inserted 8 bit. 8 bit is nothing but word. That is the minimum value which I can insert. That's what I have discussed just now. Okay, but what is the size of an ARM register actually? The size of the ARM register is 32 bit. Isn't it or not? We are having 16 registers. Everyone is of 32 bit. Even the CPSR register is also of 32 bit. Okay. If I want to try to insert an 8 bit data into an 32 bit register, where it is going to be stored? Okay. It is going to be stored in the LSB. LSB stands for least significant byte. That means, see, if I want to store some, I have 32 bit value, 32 bit. If I want to store some 8 bit value, like 1001, 1001. Okay, this is my 8 bit value. But actually, what is the size of this register? The size of the register in ARM is 32 bit. But I have stored only 8 bit. What about the rest of the 24 bit locations? Those are going to be defaultly filled with zeros. Those are going to be stored defaultly with zeros. That means out of 32, 8 bits are going to be stored with either zeros or ones. Rest 24 are going to be filled with zeros. Okay, that means here the MSB side, all the bits are going to be stored with zeros. How many bits like that? 24, because 8 bits I have filled with some value 1001, 1001. Okay, or sorry, this might be 5 bits. Na? These are 8 bits what I have filled. Okay, rest 24, these may or may not be 24, don't bother. Okay, rest 24 bits are going to be stored with zeros. Okay, thus the byte values are also, they don't store, they are not going to be stored in the MSB or most significant byte position, or they are not going to be stored in the center position. They will be stored only at the least 8 bit positions only. That is the thing you need to remember. They are not going to be stored in the most significant bit position, or they are not going to be stored in the middle position. They are going to be stored only in the LSB, least 8 bit position only. Okay, na? So that's what he is trying to do, trying to explain. 8 bits are going to be filled. Rest 24 bits are there, na? They are going to be filled with zeros. The rest 24 bits are going to be filled with zeros. Okay, if I try to store any 16 bit value, then the last 16 bits are going to be filled. For example, 1 2 3 4 5 6 7 8. Okay, delete is there. If I want to store any 16 bit value, 1 0 1 1 1 1 1 1 1. Okay, so those will be occupy the next 8 bit positions, and the uppermost 16 bits are going to be zeros. 4 8 12 16. Okay, these are going to be zeros. Okay, so if I want, okay, this is the pattern that used to take place. Okay, this is the thing that should follow. Okay, అంతేగాని ఫస్ట్ ఈ 8 బిట్ పొజిషన్స్, నెక్స్ట్ ఈ 8 బిట్ పొజిషన్స్ ఫిల్ అవ్వు. ఫస్ట్ చివర్లో ఉన్న 8 బిట్లే ఫిల్ అవుతాయి. నువ్వు 16 బిట్ డేటానే స్టోర్ చేయాలనుకున్నావు అనుకోండి, చివర్లో ఉన్న 16 బిట్ లొకేషన్స్ ఫిల్ అవుతాయి. ఓకేనా? అంతేగాని ముందున్న 16 బిట్ స్టోర్ లొకేషన్స్ ఫిల్ అవ్వవు. మరి వాటిని ఏం చేస్తారంటే డిఫాల్ట్ గా జీరోలతో ఫిల్ చేస్తాం. దిస్ ఈస్ ద కాన్సెప్ట్. ఓకేనా అమ్మా? నెక్స్ట్ this is the ARM instruction format. So the size of this register is 32 bit. So if you observe the format, we are having one condition. Okay, this is for condition build. Okay, and we are having a 00 and 00 is for 26th and 27th bit, that is predetermined, and 25th bit is I indicates immediate operand, and the bits from 24 to 21 to 24 are opcodes. Opcodes means we have discussed previously. They are nothing but operational codes. These particular bits itself they will specify what is the operation we need to perform on this particular processor, or what is the operation to be performed will be specified by these opcode bits. Isn't it or not? And we are having S bit. The 20th bit is called S bit. S is nothing but set condition code. And we are having Rn and Rt. These two are the operand registers. Or simply to say, first one is operand register and the second one is destination register. So again we are going to have another operand. Here this is first operand, this is the destination register, and again we are going to have one operand. Okay, generally we are going to have 3 operands in ARM processor, whereas in 8051 or 8086 you are not going to have 3 operands, we are going to have only 2 operands. Okay, so what is meant by an opcode and what is meant by operand? The operation what we need to be performed, okay, or the operation that is to be performed will be specified by opcode. Okay, that means depending on the opcode, the processor will perform a particular operation. If the opcode is like ADD, then the processor will perform addition operation. If the opcode is like SUB, then it will perform subtraction operation. Okay, so depending on the opcode, it is going to perform a particular operation, that is called opcode. Next, on whom we are performing these operations will be referred as operands. Okay, here in ARM processor we may have 3 operands. Yeah, we may have 3 operands. Okay, so overall this is the instruction format of an ARM. Actually it consists of 32 bits. Out of them, the second operand is of 12 bits. It will start from 0 and ends with 11. That means we are having 12 bits of first operand number 2, 3 bits of RD, 3 bits of RN, RD and a destination register, RN and a first operand register, S means set condition codes, and we are having an bits from 21 to 24 are referred as opcodes, and we are having immediate operand. Rest 2 are zeros. See, in some of the textbooks they don't mention those immediate operand and some zeros. Okay, they will just write it as opcode. Previous is a conditional field. We are having 3-bit conditional field. Okay, if you want to learn this matter in depth, that means here we are having 21, 22, 23, 24. Altogether 4 bits are allocated for opcode. 4 bits are allocated for opcode, isn't it? 21 to 24. Okay, that means 4 bits are allocated in the sense you can get 2 power 4 combinations. 2 power 4 in the sense 16 combinations you can get. Okay, for every different combination there is a different operations. Okay, what are those combinations you can see here. If I place all the 4 bits as zeros, okay, 0 0 0 0, it is going to perform AND operation. If I use 0 0 0 1, it will perform exclusive OR operation. 0 0 1 0, subtraction operation. 0 0 1 1, 3 RSB. 4 add. 5 add with carry. S6 SBC, subtract with borrow. 7 RSC, 8 test, 9 TEQ. Test is nothing but an AND operation. Okay. TEQ is nothing but exclusive OR operation. Okay. 10 compare. Compare is nothing but similar to subtraction. Okay. So these are various operations that will perform based on the opcode value what we are going to give. For example, if I give 0 1 0 0, that means 2. That means 4, isn't it or not? So for a 4, what it is going to perform? It is going to perform AND operation on two values. If I give the value 0 0 1 0, then it is going to perform subtraction operation on two operands. Okay, so what is the operation we need to perform on the available operands is going to be specified by this opcode. It is of 4-bit. So you can get 16 different combinations. For every different combination, it is going to perform different operation. Okay, and we are having two registers called RN and RD. Okay, one is first operand register, and the second one is destination register. Okay, so after that we are having operand 2. So this is the ARM instruction format. Memory addressing modes. I think it is better to discuss in the next class. Okay, whatever the time, whether it is fast, I mean, it may not take a lot of time, but I will complete or conclude here because this is the new topic what I need to discuss with somewhat separately. Those cannot be included with these topics. Okay, so now we have discussed about memory instructions, right? So once again I will revise the things in 5 minutes of time. So here ARM is what is the ARM is encoded into an 32-bit word. That means the word length is of 32-bit. Okay, you can either insert the data or delete the data in the multiples of 8 only. Simply to say 8 or 16 or 32, not even 24 also. Okay, 8 2s are 16. 16's multiple is 32. Okay, like that you can either add or delete the data. Okay, into the ARM. ARM is a 32-bit register. Here we are having two important instructions: load instruction and store instruction. Load means here the operand is going to be transferred from memory location to a register. Generally, we will prefer GPR, general purpose registers, for this load operation. Okay, and the other operation is store operation. In the store, we are going to transfer the data from registers, general purpose register, to the memory location in this store operation. Okay, so these two are the major instructions. That's what we have told. It is a byte. Okay, byte means you can either insert the data in the multiples of byte only. Okay, actually the register length is 32-bit, and if I try to store only 8-bit of data, where it is going to be stored means it will be stored in the lower order 8 bits only of a register. Rest 24 bits of that particular register are going to be filled with zeros. Okay, that is the thing what he has told. Okay, so that is about this one. Next class we will discuss. This is the ARM instruction format. It is of 32-bit. Among them we are having 4 bits per opcode, so you can get 16 combinations. Someone is conditional field, and 26 and 27 bits are fixed as zeros, and 25th bit indicates the immediate operand. Okay, RN indicates the first operand register, RD indicates the destination register, like that. Okay.